So a piecewise function is whenever you have two or more functions. So if y'all can underline the word piecewise and put 2 plus. Holy cow, is that recording? What's the number? Did I just start it? Oh, okay.
If you would look to your right.
Yeah, it's like...
Oh my god, I thought I've been recording since 4th period. Okay, I just pushed play.
It says 30 seconds. Yeah.
Oh man. Okay, I'm going to have to edit that out. Okay. I'm losing it, aren't I? It's okay. Okay, back to piecewise functions. The first part is the equation. It's your f of x, what you're going to graph. The second part is your domain. What are the restrictions? Now, if you want to, just like yesterday, you can make a table for this to graph all of it. And you can use the domain to figure out what points on the table. I'm not going to do that. Make sure you're using a pencil today. I'm going to use a pencil, graph it, and then erase based on my restriction. As we do this more, you're going to get better at it. You're not going to need to erase. But just for today, to start it off, I'm going to erase. Okay? So, the first one I'm going to graph is negative 1/2 x minus 5. How do I graph that? So y-intercept, what's my y-intercept? Negative 5. And how do I graph negative 1/2? Down 1, right 2, but that goes off my graph. So go up 1, backwards 2, up 1, backwards 2, up 1, backwards 2. Does everybody agree with that? That is my first line, and it has a restriction of x less than negative 2. This less than symbol means what? Open circle to the left. So at negative 2 for my x, I'm going to have an open circle, and I can only draw what's to the left. And I need to erase everything else. We have just graphed that first equation. Because it's s less than negative 2 and it doesn't give me two numbers, I'm going to have an arrow going on forever to the left. My next equation is negative 1. How do I graph negative 1? Nope. It's a line because y equals negative 1. So what kind of line is that? A horizontal line at negative 1. Well, what are my restrictions here? At negative 2, what am I going to have? A closed circle because it's equal to. So right there, I'm going to have a closed circle. And then at 1, what am I going to have? An open circle. And that means between negative 2 and 1. And I'm going to erase everything else. Last but not least, we have the square root of x minus 1 plus 2. How am I going to graph the square root of x minus 1 plus 2? So normally the square root function starts at 0, 0. This one's shifting right 1 up 2. The square root, the parent function of square root, then starts after 0, 0 goes to 1, 1. But instead of plotting 1, 1, what am I going to do? Right 1 up 2. It also plots 4, 2, because the square root of 4 is. But instead of plotting that, I'm going to go right 1 up 2. Oh man, I didn't look at my restriction. I graphed that before I looked at it. Oops, what's my restriction? I got lucky. It's going to be a closed circle. And it's greater than 1, so it's just going to go on forever with an arrow. Now, Is this a function? Does it pass the vertical line test?
Yes.
Yes. Why? Because we have these holes, it passes the vertical line test. So yes, it's a function. Is it continuous? What's continuous mean? I know it goes on forever in both directions, but that's not what continuous means. What does continuous mean? Do I have to pick up my pencil? I do. So is it continuous? It is not continuous. You could say it's discontinuous at x equals -2 and x equals 1. What about my domain? What is the domain of this graph? Louder? Louder. It's all real numbers. Why is it all real numbers? Because the open circle, and even then, because it literally hits every number. So could you say -infinity to -2 union with -2 to 1 union? But isn't that all the numbers? Yeah. What is my range? The lowest it goes is -4. What's the highest it goes? To infinity. So this one it doesn't go below -4. It's going to be parentheses -4 to infinity. What questions can I answer? 100%. I will say, I think in college algebra they make you draw asymptotes. Okay, you don't have to. Okay, so I don't. Okay. All right. Next one. Let's do the next one. Absolute value of x minus 2 minus 1. How am I going to graph that? Right 2 down 1. And what are my restrictions here? This one's a little bit different. Why? Not even that. It's between 2 points. It's not going to go on forever to the left. So at -4, we're going to have a closed circle. And at 1, we are going to have an open circle. And I'm going to connect those. Can you tell that this is an absolute value function based on what we graphed? No, but it don't matter. It is. Well, I started at -1. I went right 2 down 1. So when I went right 2 down 1, that's my vertex. And then you go up 1 over 1, up 1 over 1. Yeah, I just graphed the absolute value. Yeah. Because there's no vertical or horizontal stretch. And it's absolute value. Okay. How do I do this next one? Y equals -2. That's a what? That's a line, but it's only at x equals 1. It's just a point. What kind of point? A closed circle. A point. It's a point. Because it says y equals -2. That's normally a line, right? But it doesn't have an interval here. It just has 1, so I put a point. And last but not least, x minus 3. What does that do to my parabola? I'm going to go right 1, 2, 3. And I'm going to draw the parabola. And what kind of circle is this?
Open circle.
So I'm going to draw an open circle at 1. And then it's greater than 1, so what am I going to do here? Arrow. Because it keeps going. Is this a function? Does it pass the vertical line test? Yes, it's a function. Is it continuous? Can you have a piecewise function that is continuous?
No, maybe yes. Depends.
You can.
Yes, you can.
You could, like, if it would have, like, if this would have lowered and it wouldn't have the middle one, it could connect. Like, you can connect, it'd be continuous. All right, what's the domain here? Bracket -4 to infinity. I'm not going to worry about the range on this one because it's really weird and you're not going to be given anything like that. Okay? Do I have any questions about graphing piecewise functions?
No.
Can I move on? Okay. Ava, remember the other day you told me you didn't talk at all? All right, next one. Now we're going to be working backwards. I'm going to give you the graph, and you are going to give me the equation. Now, you need to have f of x equals, and you need to have the brace. If you miss any 3 of those things, I'll count a point off each time. What is the first graph that we have? It could be absolute value or linear. Honestly, you get to choose. I'm going to tell you KISS.
Keep it simple.
Sillies. Keep it simple. I think the other S stands for something else, but I'm not going to call y'all that. That's a bad word in my house.
Chris, keep it silly.
Keep it simple, silly.
Stupid.
Okay. So, could you do an absolute value? Sure. But like, let's keep it simple. Let's do a line. What's the slope of this line? What's the slope of this line? -3x. What would be the y-intercept if I kept going? -5. And then I'm going to write if. What is the restriction this gave me?
If x is less than -1.
X is less than -1. Is there a line underneath that less than? No, it's an open circle. We leave it like that. What questions can I answer? We good? What about the parabola? What did this parabola do? Left 1, so it's going to be x plus 1. Don't forget the squared for the parabola. A lot of y'all do the parentheses and y'all forget the squared. What else did it do besides go left 1? So plus 1. Does that equation make sense? If, what is my restriction here? Greater than or equal to, because it has a closed circle. And that's our answer. Yeah. Yeah, absolute value. Yeah, absolutely. Yep. That's why I wrote K. Just keep it simple. You could, but like that just yeah. Okay. On your test and on your assessment, sometimes I'm going to give you requirements. For instance, on this question, what if I gave you a requirement to write a piecewise function that had 3 different types of equations? Could you do it? Yes. Now, what do I have to start off with? F of x equals the bracket. Now, this first one, what do y'all want to make it? What type of function? Linear or absolute value doesn't matter, but if you make one of them linear, the other one has to be. If you make one of them linear, the other one has to be absolute value. If you make one absolute value, the other has to be linear. So like they have to be 3. One of the requirements on your assessment is I need 3 different types of functions. Okay? I'm going to do this one absolute value. Only because if I do this linear, 1, 2, 3, you get a ugly y-intercept. Is that okay that I don't do that? The first one I'm doing absolute value. Because if I do linear, this has a slope of -3/2, but what's the y-intercept? It's ugly. So I don't want to do it linear. So, do y'all agree the slope is 3/2? So this is going to be positive 3/2 because it's absolute value and it's going up. Does that make sense?
Yeah.
It's going up 3/2. So 3/2. We're pretending this is a v in absolute value. What is the shift happening here? X plus 3 minus 1. It goes left 3 from the origin, down 1. If, okay, so, you're not wrong. But if you choose to make the blue one a closed circle, less than or equal to, what'd you say? -3? -3. Because we're just doing the blue part. Yeah, just the blue part. Because the one right here doesn't have the same slope, so it's a different function. Now, my green line. We can't use absolute value anymore, so what can we use for the green line? Just a line. Linear. What is my slope here? 2x. And where would the y-intercept be? +5. What does this go from what to what? So if, now you're always going to do the less than symbols with an x between. You have to figure out, is it an open circle or a closed circle? Everybody look up, please. Do you see how -3 right here has a line underneath? They both cannot have a line underneath. Why? Then it would not be a function anymore. It would not pass the vertical line test because both colors are there. So if you make this one a line, this one cannot. Did I have to put a line on that one though? I could have left that open and closed this one. It's up to you. So I'm going to leave that one open and make that open. And then what about -2? That's a closed circle, so I'm putting a line under that. Does that make sense? So for your domain, only one of them for each number can have a line underneath. Last but not least, we have this beautiful parabola. What's this equation of this parabola? X plus 1 squared plus 1. It goes left 1, up 1. And what's my restriction? If x is greater than -2. Is it equal to -2? No, why not? Open circle. What questions can I answer for you? Yes. Yes, it should. Thank you. The green one should be -2. Sorry, I forgot that. What else? Ask me. Okay, if this parabola was shifted down 1, do you agree that this would be continuous? Because I could do loop.
Yeah.
Okay, so it is possible to have a continuous piecewise function. All right, could I have done this with just 2 equations?
Yeah.
Yes.
No.
No.
Why not?
Because rules.
No. Look at these 2 lines. Do they have the same slope?
No.
So that wouldn't have worked for absolute value. Because this green line has a slope of 2 and this blue line has a slope of 3/2. So just be careful that you're actually paying attention to the slopes. Just because it looks like you could doesn't mean you can. All right. Turn your paper over, please. All right. Could I make one equation here? Why? That's called the explicit equation.
Yeah.
The explicit equation here is just y equals, what is it? What's the slope? 2 absolute value of -1 minus 2. That's the explicit, meaning that's that whole equation. But what if I want you to write a piecewise function out of this? Could you do that? And I want your piecewise function to be 2 different types of equations. Go. Go. You're giving me 2 different equations. What? Okay.
Wait, can I use absolute value?
No, I want you to use what absolute value and one.
But I can't use
You can use absolute, but yeah, you have to. 2 different types of functions. So you should be using one linear, one absolute value. All right. You should have either gotten this or you might have gotten this. No. Or, these are your options. The top ones are the bottom. Or you would have gotten this. Did you get this one or this one? So it doesn't matter which one. No, you needed to do this right here or this right here. Okay, no. So the equal to does not matter. What matters is it can only be on one of them. So I switched it and did. So like if you put the equal to right here, that's fine. But you need to have an equal to on only one of them. Does that make sense? Okay. Last but not least, can I move on from this? Are we okay with reading graphs now? Thank you. Okay. All right, last thing. Shh. Hold on, I'm almost done. The last thing is reading the equations. Can I give you an equation and you apply function notation like you did the other day? So, if I ask you for f of 2, what is f of 2? Which equation am I going to use? Why? Because do you agree 2 is greater than or equal to 1? Let me zoom in, hold on. So, this equation I would use for f of 2. So, I'm going to use 2 squared. What's 2 squared? 4. So, f of 2 is 4. What questions can I answer? What about f of negative 3? Which equation would I use for that? The first one, because negative 3 is less than negative 2, so I'm using the first equation. What is negative 2 times negative 3? Plus 1? No, this has been here for years. I promise I didn't do that on purpose. Last but not least, what is f of 0? Which equation am I going to use? 0 is between negative 2 and 1, so what is my answer? Do I plug in anything? It literally is just negative 1. What questions can I answer? We're okay? Alright, here's where it gets tricky. How do I find the x-intercepts? How do you find x-intercepts any other time? What's equal to 0? When y equals 0. Well, how many different y's do I have? So I'm going to have to set all of these equal to 0. Okay, y'all look up. When you're done writing that, look up. Is it possible for negative 1 to equal 0? So obviously that's not an x-intercept. Is it possible for x equal to 1/2 for this equation? What is the restriction for this equation? X has to equal what? Does that equal less than negative 2? That's not an x-intercept. Is it possible for x to equal 0 for this equation? Why not? Has to be greater than 1. So what are my x-intercepts here? There are none. All that work for no payoff. Isn't it great? What about the y-intercept? How do you find the y-intercept? Hey, there's a lot of muttering. I'm almost done. Just hold on. When x equals 0, well, when x equals 0, what did we get as an answer?
0.
So what's my y-intercept? 0, negative 1 is the y-intercept. That's it. Last but not least, what is the domain of this function? Can you just guess all real numbers, or is it all real numbers? Why all real numbers? Because it goes from, if it's less than -2, it goes from negative infinity, and if it's greater than 1, all the way to, so what's my domain? All real numbers. When would it not be all real numbers? Like right here, you see how it goes from -4 and it didn't go to negative infinity? That would be the situation where there's not all real numbers. Okay. Wow. How do I finish so early every time in this class? A couple things. You have 15 minutes. You have homework due tomorrow. I would like everybody to get out their homework that they started yesterday. The pages, hold on. The pages are due, or the pages are on the board. It's due when you walk in tomorrow. That's what I'm about to say. Your homework, y'all. You are going to turn in your homework. We're going to trade and grade. I'm going to answer whatever questions, and then you have a quiz. Your quiz is over pages 1 through 4. It's like what the homework questions are. Okay? Now, hold on. You have a homework over piecewise functions due on Monday. So just be aware that's on the calendar as well. But there's no piecewise functions on your homework. You'll notice that. But that's going to be due on Monday. All right? So everybody, y'all have about 17 minutes to get started and do said homework.